Hey Aggies, welcome to the Week 9 test. So we're going through the Week 9 test, and remember this is a great opportunity to, number one, review your own test so you can have your test out as you watch the video, see how you did, see which things you need to focus on to do differently for the next test. And we're not just doing it to review what you did on Week 9, but remember Week 10 is going to include Concept 9 and Concept 8. That's 2/3 of this test, of the Week 9 test. Those same kinds of problems are going to show up again on Week 10. So this is the opportunity to figure out what you don't understand and to either learn it from the video or bring questions to class. All right, let's jump in. So the first part of the 9.1a, questions 1 and 2, deal with adding and subtracting integers. And we talked about using integer addition and subtraction when we talked about the wallflower dance. Hopefully you all remember doing the wallflower. So remember from the wallflower dance that what we're doing is we're showing the negative numbers. You can see it right over here. We're showing the negative numbers as minus signs or negative signs inside of a circle. We're showing the positive numbers as positive signs inside a circle, or you can just show them without the circle. And we're showing zero pairs as a combination of a negative and a positive, and they cancel out. So anytime you have that zero pair, the key thing to remember is they cancel each other out. So let's go ahead and start problem number 1. I'm not going to actually put them inside the negative, inside the circles. I'm just going to show the two negatives. So for negative 2, I've got two negative signs. I'm adding negative 4. I'm adding 4 more negative signs. In this particular problem, there are no zero pairs. If we were thinking of this from the wallflower dance, there are no couples. There are only boys at the dance. Since there aren't any girls, you can't have any couples. Nothing can cancel out. And what you're left with in this problem is negative 6. The advantage, again, of showing the model is that you can physically see. You can actually count them. 1, 2, 3, 4, 5, 6. You can see the representation of these numbers. On to number 2. So we talked about anytime we have subtraction, we are going to add the opposite. When we do that, when we change this to and add the opposite problem, it allows us to do it with the same rules we used for number 1. So we have 3 negatives, and instead of subtraction, we're going to go to addition, and instead of positive 6, we're going to have negative 6. So now we're ready to write down the 3 negatives that we have first, plus 6 more negatives, 1, 2, 3, 4, 5, 6 more negatives. And what you can see is, once again, this problem shows no zero pairs. Nothing cancels out. And when we go ahead and count, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have negative 9. All right, so at any point, if you need to review something, if you need to stop the video and play it back because something didn't quite make sense, go ahead and do that. You get to do this totally at your own pace. Let's continue on now with the second half of 9.1, and that is the statement problems. So in each of these 4 statement problems, they ask you to pick a number, pick a value that will make each statement true. So what's a possible value that makes this statement true? Well, 4 makes this statement true. If you add negative 3 and 4, you get positive 1. Here we need a positive number. You could also, for this first statement, you could have 5, or you could have 6, or you could have 7. Any of those are going to make it true. In fact, what we know is any number for this particular statement, any number that is greater than or equal to 4, any integer greater than or equal to positive 4 will make this first statement true. Letter B. Letter B, there's only one number that can make it true. If you have negative 7 and they're asking you to subtract something and get 0, the only way to get 0 is to subtract that same thing. You've known this ever since you first started working with numbers back when you were probably 2nd grade. 2 minus 2 is 0. 5 minus 5 is 0. 10 minus 10 is 0. You have to take away the same amount to get 0. Now, some of you put positive 7. You confused it with this problem. What would you add to negative 7 to get 0? If the question is, what do you add to negative 7 to get 0? The answer is 7. You would add the opposite. So you add two opposites together to get 0, but subtracting, you have to subtract the number itself to get 0. And negative 7 is the only answer that works in that one. All right, on to C. So problem C, we want to know a number that we can take 5 away from and get something negative. So when I look at this, I think of changing it from -5 to plus -5. And I know that if I want a negative number, I have to have either more negatives. If I add any more negatives to it, it's still going to be negative. That's great. Or a positive number, it has to be less than the 5. It has to be less than 5, because if I added 5 to -5, I'm back to this idea over here. 5 plus -5 would be 0. So I need some number, whatever the number I'm going to pick is, it has to be a number that's less than or equal to 4. 4, 3, 2, 1, 0, and then any negative. You can look at this, and if you're saying, well, what if I picked a negative number? You bet. On this one, this could be any negative number to make that work. Or if it's a positive, it has to be less than 4. All right, letter D. 3 2/3, we're adding. We want a negative. Have to be careful. We make sure we know what we want. So since we want a negative number, we have to be able to cancel all of this out and have something left over, which means we need a number that is -4 or less. So any number less than or equal to -4, because -4 would cancel out all of this. If you only had -3, for example, if you said, how about if I pick -3? Well, 3 2/3 plus -3 would still leave a positive 2/3 left over. So it has to be at least -4 or smaller. Remember, -3 is actually bigger than -4. Okay, again, if you have to review, stop the video, go back and look. If you still have a question, you're going to bring it to class. That's the advantage of looking these over. Right, moving on through the problem. Here we go. So now we've got a problem where we're dealing with the distance between some numbers. So when I look at this problem number 4, here's the way I think about solving it, the way I think about approaching it, is I think about looking and saying, okay, if I had a number line, both the x and the y, if I had a coordinate grid, both the x and the y, that's going to help me visualize what I'm going to do with this problem. My x and my arrow got mixed up together, so let me put the arrow in and put the x by itself. So my first number, -3, +2. On the x's, -3 is there's -1, -2, -3, and two positives. Remember, this is always the x, then the y. Two positives go up 2 spaces. There are my two positives. And there's my number, -3, 2. My second number, -3, -5, I'm going to be going to my -3 and then down. These are, if you want to think about it this way, these are the negative x's going down. These are the negative y's going down, negative x's going this way. So I would need 1, 2, 3, 4, 5 going negative, and where those two meet, that would be my second point. That would be the -3, -5 point. Then I can look at the distance between them. The distance from here to here is 2 spaces. From 0 to 2, 2 spaces. The distance from here to here is 5 spaces. 1, 2, 3, 4, 5. It's like an absolute value. So if I went 2 spaces for the first part and 5 spaces for the second part, I know that I went 7 spaces altogether, and 7 spaces would be a distance of 7 units. If you wrote 7 spaces, you got credit for it. But we would normally think of it in terms of units. All right, so now we got problem number 5, and it's a little bit bigger than the screen I have, so I'm going to need to adjust the size of the image here. Let me do that real quick. All right, I've tried to adjust it so we could see the whole thing, and it doesn't want to work. So basically, the A problem is the distance from the gym to Bob's house, and the B problem, part B, and you have it on your test, but part B is Jeff's house to the fire station. We're trying to figure out those 2 distances. So the distance from the gym to Bob's house, here's the gym, right down here. Here's Bob's house, right over here. And that distance is 1, 2, 3, 4 of these units. And they tell us that each unit, right up here, they say each unit represents a mile. So Bob's house from the gym is 4 miles. Jeff's house to the fire station. So here's the fire station. Here's Jeff's house. And the distance between the 2 of those, 1, 2, 3, 4, 5, 6 miles. Some of you mistakenly started counting at the fire station going 1, 2, 3, 4, 5. Remember, the place you start at doesn't count as the first one. Just think of taking steps. If you said that the table was 3 steps away from you, you wouldn't count where you're standing. You'd count the first time you stepped. So you just have to be careful that you count them carefully. Remember, this was the first time you saw this kind of problem. You're going to be more successful at it the next time. All right, on to the back of the page. So now we have the absolute value section and the negatives. And you've been really successful at this, so I know you did well on this one. We'll go through it pretty quickly. Negative 12 is less than negative 8. It's further to the left. If you think of a number line, number line, number line, here's 0, here's negative 8. Negative 12 is out there even further to the left. It just keeps going left. Letter B. We talked about anytime you have an absolute value, be sure that you change it to its actual value first before you go ahead and compare them. In this case, 9 is greater than 7. And then finally, negative 4 is less than negative 2, or than positive 2. We'd have positive 2 would be sitting out here somewhere, and we would have our negative 4 sitting over there. Further left means it's smaller. Number 7. They want you to list the depths in order from deepest to most shallow. Well, the biggest negative number is the deepest. This is going down below the water. Here's the water. And you're going down in the ocean. This would be 0 right here. This would be sea level. The deepest one of these would be the negative 137. The shallowest, the one closest to the surface, would be the negative 34. So if we put the rest of them in a deep to shallow, they're going to look like this, negative 83. That's 83 feet below sea level. This is negative 109. And so listed from least to greatest, from deepest to most shallow, we would have negative 137, negative 109, negative 83, negative 74, and negative 34. Deepest to most shallow. All right. Here's a problem that a lot of you got stuck on. Describe why there's no possible values of x that make the equation below true. And a lot of you said absolute value is always positive, or absolute value is how far it is from 0 to a number on a number line, but that really doesn't explain why there's no value of x. Here's the explanation you want to think about. This is saying, when you say x has a value, the absolute value of x has a value of negative 17, You're saying that x is negative 17 spaces from 0. And that's impossible. There is no number. This is the answer to this one. There is no number that is negative 17 spaces from 0. Spaces are always positive. Now, if you think, well, that's what I said, absolute value is always positive, you need to give more reason. You need to, when you're asked to describe a situation, you can't just describe it by quoting some rule. You have to give it more information so somebody really understands why the rule's true. In this case, there is no number that is negative 17 spaces from 0. Just can't happen. Nothing like that. The second part of this asked for an example and a diagram. Examples of absolute value are things like the absolute value of negative 3 is 3, and the absolute value of 3 is 3. If you wanted to get even a little more in depth, you could have said the opposite of the absolute value of 3 is negative 3, and the opposite of the absolute value of negative 3 is negative 3. But you need to have at least this much. If you only have this first one, then somebody could mistakenly think, oh, absolute value just makes numbers their opposites. You put a negative 3 in, you get a 3. I bet if you put a 3 in, you get a negative 3. You have to give them more information so they don't make that mistake. In terms of a diagram would use a number line. We'll place 0. We'll place negative 3. We'll place positive 3. Let's put some numbers in between, some intervals in between. And we would say that this is 1, 2, 3 spaces, which explains why the absolute value of negative 3 is 3. It's 3 spaces away. And 3 is also 3 spaces. That's why the absolute value of 3 is also 3. Okay, on to the last part. And again, before I scroll to the last part, if any of that doesn't make sense, you watch the video and you think about it and you watch the video and it still doesn't make sense, ask in class. There's always time to ask questions. You know we're always encouraging you to ask questions, so take the time to do that. Last one. So here is our problem for the money this time. This is that problem where we look at percents, discounts, taxes. How do we use percents when they show up as either markdowns or taxes to figure out the final cost of something? So I've got 2 boats that I'm considering here. I'm considering a boat that costs $8,500. This, by the way, let me just mark it. This is my California side. This is my Oregon side. And I've encouraged you before, separate your work out like this so you can keep track of what you're doing. So your numbers don't run into each other so much that you lose track and you write down the wrong answer because you couldn't read your own work. So on the Oregon side, or excuse me, on the California side, there is a boat that sells for $8,500, and there is 7.5% sales tax. 7.5% is 0.075. So we have to multiply it by the 0.075. Let's grab our calculator. 8,500 times 0.075 comes out to 600. 600, let me fix my 6 there, kind of an ugly 6. $637.50. That is the amount of tax. That's not the final cost of the boat, that's just the tax. Tax is always added to the cost of something. So our next step is to have $8,500 plus $637.50. So 0, 5, 0 and 7 is 7, 0 and 3 is 3, 5 and 6 is 11. Carry a 1, bring a 9 down. If you buy that boat in California with the tax, it will cost $9,137.50. Will that be more or less than Oregon? Well, let's figure out. So for Oregon, we got a little extra information. There's also a markdown, or there is a markdown, I should say, of 5%, and there's also tax of 2%. So for Oregon, we're going to have one additional step. So we start with the cost of the boat. The boat's $9,500. We multiply that by the amount of discount, 0.05. So 9,500 times 0.05. That gives us $475. That is the savings. That's how much money we get to save. I'm going to get my calculator out of here so you can see both the California and the Oregon sides at the same time. That's the savings. So our first step then, after we figure out how much we're saving, I should say our next step is to take the $9,500 and subtract the $475. Now, I did the same thing that I've told you to be careful about not doing, so I'm going to fix mine. I wrote my numbers so close together that I couldn't really read my work. So let me separate my numbers out. All right, so this is going to be one of those cases where we have to do some borrowing. Now, you could have done this on the calculator, but we can certainly do it by hand. That becomes a 10, cross it out, becomes a 9, that becomes a 10. 10 minus 5 is 5, 9 minus 7 is 2, 4 minus 4 is 0, 9 comes down, and we have $9,025. That is the discount price. You go in, or the sale price, you go in to the boat dealer and say, how much is that boat? And he's going to say, oh, today only, you can get that boat, normally $9,500. You can buy it for $9,025. Lucky you. If you go to the counter, you hand him your credit card, your American Express black card, to buy the boat, and you say to the guy, here you go, put $9,025 on my account. He's going to say, well, excuse me, but you have to pay the tax also. That doesn't cover the tax. So we need to take that amount, the $9,025, and we need to multiply that by the 2% sales tax. So I'm going to bring the calculator back down. $9,025 times 2% is equal to $180.50. That's the amount of tax. That's the sales tax. And we know anytime we've got a tax, we have to add those numbers together. So our final step is going to be to take the $9,025, add the $180.50, 0, 5, 5 plus 0 is 0, bring my decimal down, 2 plus 8 is 10, carry a 1, 1 and 1 makes 2, 9 comes down, and we've got, oh, you know what? I said 5 comes down, and then I wrote a 0 there. Hopefully you caught that. Didn't look quite right. There we go. 5 and 0 makes 5, not 0. We've got $9,205.50. The better buy right here. So right here we can see everything else being the same. You're going to buy that from the boat dealer in California. Okay, that's the Week 9 test. Remember, you're going to see 2 of these concepts Concepts 9 and 8 on the Week 10 test also. And Concept 7-1, you can always come back and say, Mr. Wilmarth, I'd like some extra study material. I want to take a test on that again. I think I can do better than I've done. And we'll set you up with something. But you got to let me know, and you got to be ready to do a little extra work. Okay, great. Watch the video if you need to watch it again or any section again, and then bring your questions to class. See you then.